Hello again. So now we're going to do surface area of pyramids and cones. So pyramid only has one base. So if you're going to draw a pyramid, again, we're going to draw a rhombus looking thing to make it look three-dimensional. And then you just put a little point above that, and then you connect that. It's called the vertex, or the apex, but you connect that to all the vertices of your base. And that's how you can draw a pyramid. So for pyramid surface area, notice that we just have this one base. So now we're only going to have one base. And then all of our lateral pieces, we're going to compare to these guys now. So this was the prism, right? Has two bases and then rectangles. And then here would be the corresponding pyramid. So you have the one base, and then all of the lateral pieces, the faces, are all triangles. So if I opened this one up, you see you have, that is the base, and then I have 1, 2, 3 triangles. So again, the number of triangles depends on the base shape. So if I looked at a hexagonal, here's the hexagon, and then pyramid, and this is another way to open this up, but I'm going to have 6 of these lateral triangles for a hexagon base. Okay, so for a general formula, the lateral area here is going to be triangles instead of rectangles from the prism. So you have one base and then all of the triangles. And the number of triangles, again, depends on what polygon base you have. Cone. So a cone, again, you're just going to have one circle base. Draw it like an oval. And to make a cone, you put just a point above that, just like we did for the pyramid, and then connect that to the outsides of the circle base. Okay, so again, the base here is a circle. It's always a circle. And then the lateral area is strange again. So this one's actually even harder than the cylinder. So remember with the cylinder, we have the cylinder here. If you cut up the side here and open it up, you have that rectangle. Well, for the cone, you have that circle base, and this is the cone. If I cut up the side here and open it up, I get this weird shape. So this would actually be considered a sector, but it's a sector of a bigger circle. So finding the area of this sector is actually a strange formula that you're just going to have to know because it takes much higher level math to prove why this works. So that lateral area for a cone is pi r L. And what the L stands for is called slant height. So if I highlight it on the cone, so this length here on the side, that length is called the slant height. So you need the slant height to figure out the surface area or the lateral area of the cone. Okay, so here, surface area is the one base, just like there's only one base for a pyramid, plus the lateral formula, which is pi times r radius times L slant height. And again, you can use this formula sheet when you are doing your test for this. Okay, so let's try some of those. So we did all of this, we did all of that. So pyramids. So there is some vocabulary that goes with this. You have your base shape, base polygon with a base edge. Your lateral, all the triangles, you have a lateral faces and lateral edges. This is called the vertex of the pyramid. And then you can do the height of the actual pyramid or the altitude to the base. You don't actually need that length until we do volume, but we will do volume very soon. Okay, like I said before, slant height, well, actually I did slant height of a cone. There is a slant height for a pyramid as well. So the slant height is actually here in the middle of the triangle. And then the height of the pyramid goes to the middle of the base. So you need that slant height, that is how you find the area of each of those triangles. So here is again the pyramid that is sort of in this format. So you have the base and then the 3 triangles coming out for that. When you have a square base like that, you're going to have 4 triangles. But you are going to find the base area, and then you're going to use that slant height because that is the height for each of the triangles. So let's try one of those. Hexagonal pyramid. So I'm going to give you a couple of hints and then have you try it. So first of all, I would always start with the base, and I would highly recommend that you redraw the base. Okay, so you have a hexagon, and then I'm going to label everything I have. So this 3√3 is pointing to the apothem. And then you have, obviously, the base edge here is 6. And that would be true all the way around. We're going to assume this is regular. So maybe we'll just write that up at the top. But these are all going to be 6. So recall that you need to know the apothem and the perimeter. So 6 times 6 is 36 in order to figure out the base area. Okay, so you need to figure out that base area. Then the next piece is we have these triangles. So notice that on the triangle sides here, right there, the base is going to be 6. And then here that arrow points to that slant height, which you need for this. So the slant height here is going to be 9. Okay, so you're going to use those triangles to figure out your lateral area. And then in the end, remember, you just add up the base plus the lateral triangles. So I'm going to have you pause and figure out that surface area. Okay, welcome back here. So you're going to do 1/2 apothem times perimeter. And for that in the calculator, you get 54√3 inches squared. Okay, the lateral area. So you're going to have 6 of those triangles. So I'm just going to write a 6, and then here, this is going to be 1 triangle area. So 1/2, 6 times 9. So again, this represents the 6 triangles around the hexagon, and then in here represents the area of one of those triangles. So I'm going to do 6 times, and then this is 3 times 9, which is 27. And then that is going to be 162 inches squared. So at the end here, you're going to add those together. 54√3 is the base area, plus all of your lateral triangles is the 162. Now, it is okay to leave your answer in that weird form. You can't add those together because this has a √3 and this does not. But you can put it in your calculator. So in your calculator, you can write 54 times √3, find an answer, and then plus the 162. And then I did that earlier, and it ends up being about, so I'm going to put squiggles here, about 255.5 inches squared. Okay, last thing here. Cone. So when you're doing the surface area of a cone, you have, again, the vertex, you have an altitude in the middle, you have that radius, and then again, you have the slant height on the side. Okay, so obviously the base is going to be pi r squared. And then as we talked about, that lateral area formula is pi RL. So if you wrote it out just the formula part, it would be pi r squared plus pi RL. So the base plus the lateral. Going through one example of that. So identify the variables here. So we have a radius of 5. We have a slant height of 10. And then you're just going to plug into that formula. So please pause and plug in and find an answer in terms of pi. Okay, so welcome back here. You should have pi r squared plus pi r L. And then simplifying, that's 25 pi. That's going to be 50 pi. And remember, this is the base and this is the lateral area. So then you just add those together. If they both have pi, you can combine like terms. So my final answer would be 75 pi centimeters squared. So with that formula, it actually is fairly straightforward as long as you plug things in the right places. Okay, that's it for surface area. We'll see you next time. If I can figure out where my stop button went. There it is. Okay, see you later.